we are going to combine 2.6, the deduction theorem, and 3.5, the appendix on proof by resolution, because they're both closely linked and both are, well, the deduction theorem is a meta-theorem that will be really helpful in proving theorems and also is valuable in terms of the theory of logic. And the appendix section on proof by resolution, I think you'll enjoy this proof, which uses the deduction theorem. So we'll be able to combine these into one class. So for our learning outcomes, we have some related to the deduction theorem and then some based on this proof by resolution. So the first two regarding the deduction theorem are simply regarding the proof of the deduction theorem, which in fact is a meta-theorem. And so you'll see in the textbook and in the notes, there's a meta-proof of the deduction theorem by induction on the length of proof. So we'll talk a little bit about that. And in order to carry out this proof, this induction proof, we need to meta-prove a lemma also by induction on the complexity of a well-formed formula. So if you're particularly intrigued by proof by induction, or you feel like you need to challenge yourself, or you need more experience with induction proofs, certainly have a look at these two proofs, and if you're able to understand them completely, then you should be well on your way to understanding proofs by induction. But essentially, the key learning outcome that you should be able to do by the end of this section is to use the deduction theorem to help prove theorem schemata. And you'll find that it's a very useful theorem to help you prove other theorems within logic. So we'll actually be able to use the deduction theorem in logic to help us out, much like we've done with some of the other meta-theorems. As I mentioned before, resolution is a proof method, and so simply the outcome for that is to use resolution to prove various theorem schemata. And although within this video you'll see it has a lot of parts to it and a lot of explanation, in terms of the application of a proof by resolution, it's pretty straightforward. It's a pretty straightforward method. It has a particular method to follow. And so unlike some of the other proofs that we do within logic where you have to really be paying attention, looking ahead, trying to determine what axioms and what other theorems you need to use, resolution tells you exactly when to use which theorems. It also helps you, if you get really comfortable with resolution, helps you to be comfortable with some of the theorems we build to be able to help you throughout all of the other proofs.